Hey guys, welcome back. This is going to be the solutions to three of the six complicated circuits that are on the back of the circuit packet for labs. So I want to go through a few of these to help you guys along. So here's our circuit and here is our chart, and I'm going to call this resistor R1, this resistor R2, and this resistor R3. And I'm going to fill these into the chart as well as putting 12 volts in my chart. So I have 12 there, I have 30, I have 20, and I have 10. The first thing I want to do is find my totals. So those are all in parallel. The path splits, so I can do that my R total is 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. So this is going to be 1 over 30 ohms plus 1 over 20 ohms plus 1 over 10 ohms. And this should be less than the least resistor. It's like 1 divided by 30 plus 1 divided by 20 plus 1 divided by 10. I have 5.45. So I'm going to call that my total. All right, now I can get my total current because I'm assuming that this is all ideal conductors, so I can use the equation that is derived from Ohm's law, which is V equals IR. So I total is going to be V total over R total, so this is going to be 12 volts over 5.45 ohms. And that is 2.2 amperes. Now I'm going to remember ISVIT, which tells me that current is the same in series and voltage is the same in parallel. And since these are all parallel, I am going to get 12s for all of them. And now the individual currents, again, will follow from the equation derived from Ohm's law. So I'll take the individual voltages divided by the resistance. So I'm going to have 12 over 30, 12 over 20, and 12 over 10. That one I don't need a calculator for. The other ones I probably should use a calculator. At this point here, I know that my total current's 2.2. I'm saying 1.2 is going the R3 path, 0.6 is going the R2. So together these are 1.8. So that means that 0.4 must be going the other path. Or I can do the 12 divided by 30, and I also get 0.4. So there's more than one way to do that, right? Because the current has to be conserved. All right, now I have a combination. Again, I'm going to call the first resistor I encounter R1, the second one R2, the third one R3. And I'm going to plug these values into my chart, and I know that I have 10 volts. All right, so I need to try to combine all of these resistors together. In order to do this, I'm going to simplify this by combining R2 and R3. So I'm going to combine that. And I'm going to call that R23, which isn't a real resistor, but it would do the same thing as R2 and R3 are doing in this circuit. So this is going to be 1 over R2 plus 1 over R3. So I have 1 over 8,000 plus 1 over 10,000. And I have 4,444 point repeating fours. Where does this go in my chart? Nowhere. Because there's no place for R2, 3, because it's not real. But I can add this to R1 and get R total. And so this is going to be 2,000 So I have 6,444. Now I can get I total by taking V total over R total. Now I'm going to round here, which I know when I solve for the things the two different ways, it's going to add to some inaccuracies. All right, now that I know this, I'm going to remember ISVIP. And ISVIP tells me that current's the same in series, voltage is the same in parallel. So these two are in parallel, they're going to get the same voltage. But that doesn't really help me because I don't know what that is. It's going to be whatever's left after that one uses it up. But this guy is actually in series with the 10. All of the current that comes out of the battery and enters the battery has to go through this first resistor to make it to the other side. So I'm going to put this up here. And so I can get V1 because that's going to be I1 R1. And so this is going to be 0.0016 amperes times 2,000 ohms. 3.2 volts. All right, so I start with 10 volts. Why don't I switch colors? I start with 10 volts. When I go across this resistor, I lose 3.2 volts. So 10 minus 3.2 gives me 6.8. And the idea is that each of these gets 6.8. They don't split the 6.8, they each get 6.8 because all of the potential needs to be used up in a total loop. And so this one's going to be 6.8 and this one's going to be 6.8. And then it's going to be easy for me to get these missing currents now. So I can get I2. I can say that I2 is going to be V2 over R2. So I'm going to say that I2 is going to be 6.8 volts over 8,000 ohms. Which I have 8.5 times 10 to the negative 4th amperes. So that's going to be 0.00085. And then I know that this has to be made up of this and that, right? Our current has to be conserved. So if I take that minus that, I get 0.00075, or I can say that I3 is going to be V3 divided by R3. not quite the same, right? I got 0.00068.00075, but I rounded a number of places. So it's near what it is. I didn't write this question. I believe Greg Jacobs did. All right, last example. This one gives us some other unusual things. I don't know what the battery is in this one, but I'm going to call this one R1. I'm going to call this one R2. And I'm going to call this one R3. So I know that this is 50, this is 100, and this is 70. And I know that the current that's going through R2 is 21 milliamps. The prefix milli is 10 to the negative third. So keep in mind that an amp is a lot. So if we're talking about, circuits like this, very often we'll have a lot less than an amp, so it's safe. So this would be 21 divided by 1,000 or 0.021 amps. And that's going to go here. All right, there's a couple different ways we can go. I know all three resistors, so I can find my total resistance, or I know I2 and R2, and I can get V2. Let's do that one. That one's a little bit different. So I could say that V2 is going to be I2 R2. So this is going to be 0.021 amperes times 100 ohms. And so this is going to move my decimal point 2 places, and that's going to be 2.1. But what does this give me? Well, I know that R2 and R3 are parallel to each other. What does ISVIP tell me? That they have the same potential, same voltage. So that means that this is also 2.1 volts. Well, what's that going to allow me to get? I3. Now, I3 is not going to be the same as I2 because even though the voltage is the same, the resistance is different. Excuse me. So I3 is going to be V3 over R3. So this is going to be our 2.1 volts divided by our 70 ohms. And so I have 0.03 amperes. So this is how much the split current is for each one. Well, the total current has to be the sum of the two of them because the amount that's going into the junction where they split has to be the same as the amount, I'm trying to do this by looking at the thing, that is coming out there. And so my total, which is also the current through 1, because all of the current has to go through R1, is going to be equal to 0.021 plus 0.03. So I have 0.051. I can put that here, and I can put that there. So now I can get V1, because that's going to be I1 R1. And again, I don't have to go this way. I could go this way, go that way, and go that way too. There's a lot of different ways to finish this at this point. But I'm going the unconventional way. So I have 2.55 volts. Now, I also know that all of the potential has to get used up in a total loop. What are my two possible loops? It is the battery in R1 and R2 and back to the battery, or it's the battery in R1 and R3. So how much is that? That's this voltage plus that voltage, or this voltage plus that voltage. So this is going to be 4.65. And then again, there's going to be two ways to fill this in. And again, we could have started there because we had those resistors, right? Decided that why not do it backwards? So I can get R total by taking V total divided by I total. So this is going to be 4.65 volts divided by 0.51 amperes. And I got 91.2 ohms. All right, let's do it the other way. So first, I need to combine the resistors that are in parallel. I'm going to switch colors. And my resistors in parallel would be the combination of those two. I would call that R23. That would be the one resistor that could take the place of both R2 and R3. And that's going to be 1 over R2 plus 1 over R3. R2 is going to be 100. R3 is going to be 70. I got 41.2. And now our total is going to be R1 plus R23, which R23 doesn't exist. It's very much like our components. It's just something that we use that helps us to solve the problem. And this is going to be R1, which we said was 50, plus 41.2 is 91.2. And those match up perfect, which we just lucked out, right? We didn't have to have any rounding in them. All right, so I did the first three together with you. Keep in mind, looking at that paper, if you're in general physics, regular physics, my fourth period, you don't have to do all of them. There are a couple that say AP only. The answers are on the back of the page, but I would like to see the work, and I would like you to complete them correctly.